Yum. Lila, tell them how the treat is. Yum, yum, yum. Tell them how it is. A little camera shy. Say hi. Okay, let's talk about inverse function. Okay, so let's start with the formal definition of the inverse of a function. It says here, let f and g be two functions such that f of g of x equals x for every x in the domain of g, and g of f of x equals x for every x in the domain of f. Woof, that's kind of a lot of words. Let's really focus on some things here. I really want you guys to focus on the part that talks about the domain. Okay. We spent a lot of time talking about domain. It's really important to consider the domain when we talk about inverses of functions. One thing, and I'd like you to write this down, is that under these conditions, the function g is the inverse of f. Again, taking a look at what our actual definition said that when we compose f of g of x, and that equals x, and we compose g of f of x that also equals x, we therefore know that they are inverses of each other. So I'm going to write this down, that g is the inverse of f. Now notice that this isn't f to the negative 1 power. Okay, this is f inverse. Let's think about notation. And we also know that f is the inverse of g, right? Again, assuming that these conditions are true. Now, another thing that's really important to note is what it means to be one-to-one. We're going to write this down as well. One-to-one. That means that every element of the range corresponds to exactly one element of the domain. I'm even going to highlight this just because I like using the highlighter. Okay, so one-to-one, we know that every element of the range corresponds to exactly one element of the domain. Okay, so we're also going to think a little bit more about what that means. Oops. Okay, so let's get my pen back here. So something that we want to keep in mind is that the domain of f must equal the range of its inverse. Likewise, the range of f must equal the domain of its inverse. Or to put all of this into short-term words, if I have two inverses of each other, their domain and ranges are switched. Okay. Last note that we're going to write to ourselves is that f and f inverse would be reflections. So if we're thinking about a graph, are reflections of each other over the line y equals x. It's kind of an interesting thing. be fun to play around with. Okay, so, oops, I'm sorry. So I know that's a lot of information, but really want to hit home both algebraically and graphically what it means to be an inverse and also what it means to be one-to-one. So let's take a look at some graphs. Here are 4 graphs, and the directions say that 2 of the functions, these are all functions, right? We could verify that in several ways, right? One of the ways, kind of a middle school term, is that vertical line test, right? You could use the vertical line test and confirm that all of these are functions. But we're curious which ones are one-to-one. So not just functions, but one-to-one. So just take a look at them. Remember what it means to be one-to-one. Okay, look at your definition that you just wrote above. So go ahead, put me on pause, and really think about it. All right, so here are 2 functions that are one-to-one. Take a look at these graphs, see what they kind of have in common, see how they differ from these other 2 that are not one-to-one, and also think about our definition of what it meant to be one-to-one. Remember, that was that every element of the range, so think about the range of this, corresponds to exactly one element in the domain. Okay? Sometimes we refer to this as the horizontal line test. To be one-to-one, does it pass the horizontal line test? For these 2 that I marked as yes, yes they do. Okay, so you may be a little overwhelmed. There's a lot of work on this page. Do not fret. It says the following 2 functions are inverses, and explain how my work shows this. Okay, so you guys can see my work on here. Feel free to take your time to kind of look through this. This is f of x, this is g of x, and kind of look at the work that I've shown here. Notice what I have done. Okay, so I want you guys to take a minute to really dissect this work. I'll keep it on this page for a minute. Feel free to pause it if I'm going too fast. Think about it. Why does this type of work show that f and g are inverses of each other? So put me on pause the screen if you need to look at it more, and explain in words, articulate why or how you know. Okay, last example. It says right here, find the inverse of the following function. So notice that we have this quadratic. If the inverse does not exist, and that would be because it's not one-to-one, then restrict the domain so it does. So let's first think about what this graph looks like. I'm gonna just create a little graph here. All right, ooh, transformations. Good thing we spent some time on it, huh? You're welcome. You know, I know that this is gonna be a parabola. Okay, beautiful. So remember, it said if the inverse does not exist, then restrict the domain so it does. So currently, is this one-to-one? Or I kind of gave you guys an idea to think about this, that horizontal line test. Currently, it's not one-to-one, but we could restrict the domain. In fact, it does hint at that. Restrict the domain that it does, so that it does. So let's take this portion of the graph that I'm putting in my cute little box here. This portion of the graph would be one-to-one, right? Think about it. All the elements of the range are assigned to exactly one element in the domain. That is true. I could have also restricted the domain to this left part of the graph, but whatever. So let's actually make a note of that we restricted the domain. Oops. Restricted the domain. So what is that domain that we have now? Way to go. Good answer. 2 to infinity. Okay. So now it says find the inverse. So perhaps you remember how to do this algebraically. Don't forget that we always start by switching the x and the y. So instead of having y equals, I'm going to have x equals x minus, oh lordy, y minus 2. Silly me. It is summer after all, for me at least. So I switched the x and the y, and you guys are going to solve for y to find the inverse. So I'd like you guys to put me on pause and actually do that. Don't just wait for me to have all the work and showing you what to do, because you are the student after all. You need to learn. Okay? So put me on pause, solve for y. Go! Okay, I'm giving you one more chance to actually do this on your own before you see my answer. Okay, well, I solved for the inverse of this function f of x, and if you got this right, you should have gotten that f inverse of x equals the square root of x minus 1 plus 2. So something I want you to think about, because we did spend some time talking about the domain and range of f versus f inverse. You know, if I were to graph this, and I'm going to use yellow, sometimes I feel bad that yellow gets a little left out because it's just hard to see, you know? If I were to think about the domain and range of this yellow graph, my inverse, versus the domain and range of this part of my original graph, they are switched, which, boom, that's exactly what we said they were supposed to do. So cool. Okay, conclusion. Domain and range switch because of a function and its inverse function, between a function and its inverse function. Inverse only exists if a function is one-to-one. Super duper important. Some people don't remember. Domain of inverse is range of original function, and range of inverse is domain of original function. Or in other words, that's what it says up here.